Hello everyone and welcome back to my channel. This is just going to be a quick video on grade 11 physics, calculating forces using Newton's laws of motion. So let's jump right into it. So a block with a mass of 5 kilograms is pulled over a rough surface by force F of 50 newtons. Now, remember, when they say rough surface, there is always going to be a friction force. Okay. Further, they say the block accelerates with a magnitude of 2 meters per second squared in the direction of the applied force F. Now, let's look at the first question. Calculate the magnitude of the friction force F. Okay, now let's quickly look what they gave us. They gave us the applied force, which is 50 newtons, and they gave us the acceleration. We also have the mass of the block, which is 5 kilograms. So if you want to solve this question, I have a tip. Always use a free body diagram first, because a free body diagram just shows you and it gives you a better understanding of all the forces that is working on your block. Okay, the block is on a horizontal surface. There is an applied force, F. There is a force that is always working on everything in the universe. What is that? That is our gravitational force downwards. The block is standing on a surface, so the surface is simultaneously working a force onto the block, and that force we call the normal force, and that is upwards directly from the surface. And of course, because the block is being pulled, there is a applied force, there is going to be friction force, because why? It is on a rough surface. Now they're asking us to calculate the magnitude of the friction force. Now, what formula are we going to use? We're going to use Newton's formula, and that is F net is equals to ma. Now we just substitute the information that we have. We have the mass of the block, which is 5 kilograms. We have the acceleration, which is 2 meters per second squared. Okay, now listen. Because the frictional force is working on the horizontal area of the block, we're only going to use the horizontal forces, the components of the F net that is on the horizontal, because our friction is only working on the horizontal force. Okay, now those forces are our applied force, also our friction force. Now, why is that friction a negative? Because the block is being pulled this side, okay? So we're taking right as positive, thus meaning all the forces that are moving to the right side we are going to count as positive, and all the forces moving to the left side we're going to count as negative. Okay, our applied force was 50 newtons minus our force of friction is going to give us 10. So simple calculation, so we can see that our force of friction is equals to 40 newton to the left. Always add to the left. You're not going to say negative 40, you're going to say 40 newton to the left, because it is working in the left direction. Okay, next question. Calculate the coefficient of friction, and of course that is the Greek letter m. Okay, what formula are we going to use? We're going to use this one. our force of friction is equals to our coefficient of friction times our normal force. That is going to be the only formula that includes the coefficient of friction, which we can find it for. Okay, now we've already calculated the force of friction, which is 40 newtons. So you can just add the 40 there, times our coefficient of friction. Now we need our normal force. Now how are we going to get that? Remember, because the block is on a horizontal surface, the force of gravitational pull is exactly the same as the normal force because it is on a horizontal surface. For example, if this block was not on a horizontal surface, if it was on a surface like this, the block would be there. So our normal force is always working directly with our surface. So the normal force would be in that direction. And our force of gravitational pull is downwards. You see, so now the two forces are not the same. But here they are directly under each other. So the normal force is equal to the gravitational force. Okay, so we're going to calculate that by mass times our gravity, and so you can just fill that in. Is 40 is equal to our force of friction. The mass of the block was 5 kilograms, and what is our gravitational? It is 9,8. So now we can just add that to our calculators, and we can